I want to find the Norton's equivalent circuit for terminal A and B for the given circuit. So what I will do, I am just redrawing the circuit here with terminal A and B short circuited. So this is plus there, minus there, 10 I naught, 2 ohms, and this is terminal A and terminal B short circuited there, and this is I Norton, which is also I short circuit, and this one is I naught here, which is the control current of this current controlled voltage source. This is 2 amps there. So the voltage at this point, if let's say this is the reference voltage, which is 0, the ground voltage here, so the voltage at this point will be, since the current is I naught and the resistance is 4 ohms, so voltage drop here will be 4 I naught. So at this point voltage will be 4 I naught. So if I write IN, which is I Norton, that is the current through this 2 ohms resistance, so that will be so let's say we write KVL in this loop. So this voltage drop will be 2 IN, I Norton, I Norton. So if I start from here and go in the clockwise direction, I have a rise of 4 I naught. So instead of writing I naught, I will write 4 I naught is the rise, and then I have drops 10 I naught and 2 IN. So 10 I naught plus 2 IN. I have used caps lock and I have used capital and small here, I naught, but I will leave it like that. So IN is in capital and that's in small, so like that. So this is minus 6 I naught. So IN is minus 3 I naught. This is a relation that I get. So basically I have just written KVL in this loop. So that's one. Now what I will do, I will write KCL at this node. So that will be 2 is an entering current is equal to I naught is leaving, and also and IN is I Norton is also leaving. So like that. Now instead of I Norton I will write 3 IN. Instead of I Norton I will write minus 3 I naught. So that will be minus 3 I naught. So minus 2 I naught is equal to 2. So I naught is equal to minus 1. This is what I get as I naught. So now I have the circuit like this. This is 2 amps. There is a current which goes upwards, actually 4 ohms, which is I naught, and then there is this voltage drop plus minus, which is 10 I naught, and then 2 ohms, and then short circuit, I short circuit. So basically my I naught becomes minus 3 I naught, IN becomes minus 3 I naught, which is minus 3 times minus 1, so 4 amps. So that is Norton's current. So it goes like that. And now I need to find the resistance, Norton's resistance. So this is IN, which is 4 amps. In order to find Norton's resistance, what I will do, I have this circuit. So I will go back to the original circuit and I will, since there is a dependent source here, instead of I cannot make the dependent source inactive, so I will apply a 1 ampere current source here. Just it is a 1 ampere current source just here, just to find the resistance. So then I will try to find the voltage drop across it, and I will divide the voltage drop by 1 ampere to get the resistance. So this is 2 ohms, this is 4 ohms, and this one is 10 I naught, this is I naught there, and this source will be inactive, so this will be open, so there is no branch there. So now I have just one loop here, and I can write I know that I naught here is 1, that's 4 actually, sorry, here it's 1, IN is 4, so that's 1 ampere, because this is the 1 ampere current source that I have connected, and that's the same current that's going there. So that's I naught. So I need to find what is the voltage drop here. So if I call it whatever VO maybe, and I write KVL for this loop. If I do that, when I start from here and go counterclockwise, go in the counterclockwise direction, I get V naught first as a rise, then current is going in this direction, so that will be a drop 2 times 1 because current is 1, and then I have a rise of 10 I naught, and then I again have a drop of plus 4. That's 10 I naught because this is the current dependent voltage source there, and this is 4 times 1, so 4 I naught, that's I naught is 1, so 2 here, and this is 10 here, and then plus 4, so that is 6, so minus 4 volts there. That is the value of the voltage. So our resistance becomes, so this one means that the value of the current source will be in the other direction, so 4 minus 1, so that's 4, so I will just take the 4 ohms value, so the Rn is 4 ohms, so that's the Norton's resistance, and this is terminal AB. So the whole of the left part of the circuit is replaced by this Norton equivalent circuit.